Hi everyone, today we're going to discuss how to find the domain. We're going to do so by looking at a graph for the first couple of examples, and then the examples after that will be a bit more involved and we'll deal with equations. First of all, what does finding the domain actually mean? Finding the domain means finding all possible values of x that yield an output y. This may seem a little bit confusing, but let's look at an example. Let's look at this first example, which is a square root function. What do we notice? We notice that before x is equal to 1, so everything smaller than x is equal to 1, the function is not defined, meaning we have no value of y for values of x that are smaller than 1. So the function effectively starts at x is equal to 1. And we see as we go bigger and bigger in terms of x values, we always have this function value. This means that our domain is x greater or equal to 1. The 1 is included. This can also be written as, we're going to use a square bracket to mean that we include the 1 all the way to infinity, and infinity is always excluded. So we use this round bracket. Now moving on to our second example, which is an absolute value function. Well, what do we notice? Let's scan from left to right, as we did in the first one. The first one we scan starting from the left, the function is not defined, we have no y values, and then they start being defined at 1. Now here if we scan, well, we notice that this function is really never stopping as we go to negative infinity. And if we continue scanning, the function never stops. It's maybe easy to get confused with these absolute value functions because it seems like they're ending here, but they're effectively really continuing on and on and on until infinity. So our domain here is all real numbers, which we can represent as negative infinity all the way to positive infinity. Now moving on to our final example. Illustrated here is a rational function. Let's do the same exercise as before. Let's scan starting at negative infinity in terms of x and see where the function is defined. So if we start here all the way to x is equal to 0, we see that we have y that's defined, right? And then it seems to fall off here at x is equal to 0 and then resume right after, right? All the way until infinity. So this x is equal to 0 is what's called an asymptote. And it means that no functions are going to be, or the function is not going to be defined here. So we need to exclude it from our domain. So we do this by saying that we start from negative infinity, right here, and the function goes all the way to x is equal to 0, but it is excluded, which means that we use this kind of bracket here, and we do a union, which is represented by this kind of U-shaped symbol, 0 to positive infinity. So this part effectively represents this, and this part this. Now let's move on to dealing with equations. For the graphing questions, we were looking to find where the function was defined. When you're dealing with equations like this and you're asked to find the domain, you want to find the inputs, meaning the x values that will break the equation. So values that will break the equation occur under two main cases. 1, a division by 0, and 2, a negative inside a square root. So let's remember that the domain is all possible values of x that yield an output y. So if we look at this first example here, which in turn is literally the last graph that we graphed here, we have a division. So the first thing that we should think of is the potential for a division by 0. So if we were to have 1 over 0, this is a division by 0, meaning that the input x equals 0 breaks this equation. This therefore means that x cannot equal 0, and that would be the answer for the domain, meaning it's really all real values except 0, which is functionally equivalent to this here. Alright, if we do the next one, we have a square root. So now the input that could break the equation is a negative inside this square root. So the way that we're going to write this out is the domain is valid when x minus 12 is greater or equal than 0, right? So our domain is going to be, if we do plus 12 on either side, x greater or equal to 12. So this is going to be the domain. Okay. Next, moving on to x plus 1 over x plus 2. We have a division. So once again, we have to find for what value we're going to have a division by 0. So we therefore have to do x plus 2 cannot equal 0, meaning x cannot equal negative 2. And that's it. Now let's move on to a little bit more complicated examples. Now let's look at D, which is f of x is equal to square root x plus 3 divided by x minus 3. So you should notice two things. We have a division, so we have to check for the potential of division by 0, and we also have a square root. So we solve this in two parts. First of all, x plus 3 must be greater or equal 0, therefore x greater or equal negative 3. Now because of the division, x minus 3 can't be equal to 0, therefore x cannot be equal to 3. So we can't just leave it like this, we have to combine these answers. So let's draw kind of a timeline to see what's going on. So we have 0 here, we have negative 3, and we have 3. So this first condition here says that x is bigger than negative 3 included. But then this second condition here says x cannot be equal to 3. So we have a discontinuity here. So we have two intervals. The first one here from negative 3 to 3, and the second one from 3 to positive infinity. So we will write this out as 3 included all the way to 3 excluded, union 3 excluded to positive infinity excluded. All right, let's do the same thing for the last example, which I consider to be the hardest one. We have a division, but within the division, in the denominator, we also have a square root. So let's start off with the can't equal 0 for the denominator. We have 3 minus square root x minus 3 can't be equal 0. Let's bring the 3 to the other side. We therefore get negative x minus 3 can't be equal to negative 3. Let's do a divided by 1 to get rid of the negative. So we get x minus 3 cannot be equal to 3. All right, now we'll continue here. How do we solve this? Well, we want to get rid of the square root here. How do we get rid of a square root? We do the inverse operation to a square root, which is to square it. And if we square this, we also have to square this. And by squaring this, we simply just get the value inside, right? So we get that x minus 3 cannot be equal to 9. Therefore, x cannot be equal to 12. All right, so that's the first part, right? And then we have the second part here where x minus 3 bigger or equal 0, x bigger or equal 3. So now we have to combine the two. I'll let you pause here if you want to try it yourself. All right, so the final answer is 3 included all the way to 12 excluded, union 12 excluded to positive infinity.